Ladies and gentlemen, welcome to the main event.
Welcome back to another episode. Today, we're diving deep into DevSecOps, a game-changing approach that integrates security directly into the development process. It's all about creating software that's secure by design.
That's right. DevSecOps aims to blend the rapid pace of DevOps with the necessary security measures, ensuring vulnerabilities are managed proactively. A lot of people still think of security as an afterthought, but DevSecOps flips that script. Let's break down how technology plays a role in all of this.
For sure, the core idea of DevSecOps is embedding security right from the beginning of the software development lifecycle. We're talking about everything from coding to deployment, making sure vulnerabilities are addressed at each stage.
And technology is the key enabler here. From identifying vulnerabilities early on with automated tools, to managing those risks in a way that allows developers to stay focused on their tasks, technology is constantly working in the background. But let's get into the stages of vulnerability management, which are crucial.
Absolutely. So there are three major stages in vulnerability management: identification, observability, and management. You can't fix what you don't know is broken, right? The first stage is all about identification, using tools to find vulnerabilities in your code, dependencies, and even infrastructure.
That's the tricky part. Security isn't just about scanning code. There's so much more to it: containers, third-party dependencies, even the way your infrastructure is coded. And those vulnerabilities often come from places outside your control, like open-source libraries.
Exactly. And once vulnerabilities are identified, we move to the observability stage. This is where things get interesting. It's not just about knowing there's an issue. It's about translating those technical details into something actionable for non-security teams.
Right. In a typical company, the developers might not be security experts, and the product owners or managers are even further removed from the technical side. So you need a way to take all those raw vulnerability reports and present them in a way that helps decision makers prioritize what to fix first.
That's where tools like Application Security Posture Management, ASPM, come in. These tools can take all the findings from different scanners, prioritize them based on severity, and give managers a single, cohesive view of the risks. This helps them decide what to work on and when.
And let's not forget the management stage, which is where all the action happens. This is where the decisions are made, which vulnerabilities get fixed, and when. It's a delicate balance. You can't drop everything for every issue, but you also don't want to let critical issues slide.
Exactly, and to manage that, teams often use tools like Jira or other ticketing systems. But the real challenge is deciding what to fix first. This is where service-level objectives, SLOs, come into play. SLOs define the timelines for remediating vulnerabilities based on their severity.
Right, and sometimes a business decision might take precedence. For instance, a new feature might be prioritized over a lower severity vulnerability. But those decisions need to be informed and transparent, with clear communication across teams.
Absolutely. So, let's talk about what happens before we even get to the management stage. The whole point of DevSecOps is to stop vulnerabilities before they even get to production. And that's where the concept of secure by design comes into play.
Secure by design means that security isn't bolted on at the end. It's integrated from the start. In the pipeline, there are security gates at every stage, ensuring that vulnerabilities aren't introduced in the first place. From pull request checks to container image scans, everything is automated and continuous.
That's a huge part of the shift to DevSecOps. It's all about embedding security into the developer's workflow. Rather than having a security team come in at the end of the process, developers themselves are responsible for security from day one.
And this doesn't mean developers are on their own. They have tools integrated right into their development environment. For example, security scanners are part of their IDEs, meaning developers get instant feedback on vulnerabilities as they write code.
Yes, and that feedback is crucial. It's about minimizing friction and ensuring that developers can address security issues without disrupting their flow. With pre-commit or pre-push hooks, you can catch problems before code even gets pushed to the repository.
Now let's talk about containers and Kubernetes. When you're deploying your application, the last thing you want is for a security vulnerability to slip through after all that work. But you can set up additional security gates around the container images before they're even deployed.
Exactly. Scanning container images is a critical security step. If there's a vulnerable dependency in the image, you need to catch that early. And using tools like Kubernetes admission controllers can help detect issues even after the container is built, before it's deployed.
So this brings us to the concept of pipeline integrity. How do you ensure that the pipeline you've built isn't compromised? This is all about securing your build and deployment systems. You need to verify that your pipeline is producing trustworthy software and hasn't been tampered with.
That's right. One way to do that is through reproducible builds. If you can verify that a build is identical no matter where it's produced, you can be sure it hasn't been compromised. And then there's artifact signing, which is like a digital fingerprint for your software. It ensures the software came from a trusted source.
And that leads to the importance of securing the entire software development pipeline. Not just the code, but every system involved. From the workstation where developers write code, to the build servers, to the deployment systems, each of these systems needs to be protected to avoid compromise.
A great point. The concept of zero trust networking is becoming more critical here. It's about restricting access between services and making sure that if one service is compromised, it can't affect the rest of the pipeline.
Exactly. And it's not just about the infrastructure, but also about identity management. With so many different systems interacting, you need to manage both human and machine identities carefully. Secrets management plays a big role in ensuring sensitive information stays protected throughout the pipeline.
Yeah, secret leaks can be a huge risk. That's why having robust secret management practices and detecting leaked secrets quickly is crucial. In fact, some teams even use honey tokens, fake secrets, placed intentionally in source code to trap attackers.
Such clever tactics. And as we wrap up, it's clear that DevSecOps isn't a one-time fix. It's an ongoing journey of continuous improvement. The landscape is always evolving with new threats and technologies, so organizations need to stay agile.
That's the beauty of DevSecOps. It's about building a secure development pipeline from the start and adapting as new challenges arise. The goal is to keep evolving, making security an integral part of the software lifecycle, not just an afterthought.
And that's it for today. Thanks for joining us on this deep dive into DevSecOps and security by design. If you're implementing these practices in your own organization, remember, it's all about continuous improvement. Stay secure.
Until next time.
A special thank you to MarketUS.com for furnishing us this information. You can reach them at MarketUS.com or call them at 954-636-3232. Before we go, this deep dive was created by the MarketUS.com team. Let us know your thoughts in the comments below. It's right below the subscribe link.